Thank you very much. Hello and welcome everybody to this session of feature-driven architecture. I'm brave, but I'm still nervous. So let me quickly switch the slides here. And someone took my presenter, I think. Christian? No. No? Oops. No worries. Thank you very much. Then yes, I will talk today about vertical slices. You see a pizza here. For sure I'm not talking about pizza, but today so many new faces are here, and I would like to get to know you better a little bit, and I would like to start over with a short survey or poll. So please pull out your phones, scan the QR code, and we will start with that one. Yes, thank you. Just wanted to wait. I will switch to the poll itself. You now have the possibility to scan the QR code again, but I guess everybody has scanned it. Here's also the link. But if that's working, I will start with it. So, icebreaker question, who of you loves pizza? Unfortunately, we don't get one today, but I think there is other good food here. The first time I attended the .NET Stammtisch, we got one from SmartPoint Dataformers. Okay. I guess that's a good result. I recently figured out that people in their 30s are searching for either a gravel bike, doing a triathlon, or buying a pizza oven. So definitely all of you love pizza, or most of you. The one who hate pizza, we will just skip that for now. Then, which of the following jobs describes your current role best? Software engineer, software architect? Are you from product management or something completely different? (30, 40 votes. That's good. Thought that most of you are software engineers or architects. 2 product managers here. Okay, then do you know or use vertical slice architecture? If everybody or most of you says yes, then we can grab a beer now. And I will thank you. Okay, good. 38 votes, 40 votes. Never heard of it, most of you. That's quite good. And that's why I'm talking about that topic today. And I have one last question. What architecture structure do you usually use in your current product, software? If you are in a project company building multiple software projects, then yeah, I will guess you have a go-to architecture you use. Okay, 38, 39. One last vote, I guess, that we are under 40. No? Okay. Layered architecture is the most architectural structure used here. I already guessed it, or I hoped at least that this is the result of this survey. So this was it. Thank you very much for doing the survey. So let me just switch back to my slides. Oh, no, I just wanted to show you a sample app I built. Sorry, nothing. I hope my writer works because it broke several times. I just created a sample application using a pizza receipt book because I love pizza too and just needed a showcase for that. Some of you are familiar with this kind of software architecture or software structure. I created projects and called them application domain host infrastructure. What is this architecture structure called? Some of you said that you use it in your current project.
Clean architecture.
Clean architecture, thank you very much, from Uncle Bob. This is really just a small showcase. I created it with the main entry point. Let me just show you. Here is our program, C#. It's really, really simple. Just to show it, just for showcase, I added 2 repositories here and an author service. Let me just show you the application folder where we have our feature implemented. Let's say we have an author service where we collect our methods to do things, to create an author, to get one, to get all authors for drop-down select. Let's assume this is our backend for frontend, so we know that only our team members will call our endpoints, and this is the service class. Let me show you the controller. Here I've created a controller class, but not with the standardized controller which extends the base controller. I created minimal APIs, 3 of that here. Map create author, map get author by name. And here you can see I injected the author service, and let me switch to the author service itself here. I call the author repository and I select the author DTO, which will be the response type, so an IEnumerable with ID, first name and last name. And you could already see that here we might have a problem. We might have. Anybody has an idea what I'm doing wrong here? Or wrong is? Yes?
You're returning the domain model from the repository.
Yes, I'm returning the domain model, and I'm doing the select in memory. So I already get all data in memory and just select the data then. And now let's assume we have a repository with a few thousand lines. And I was in projects, or at least I know projects where this is really the case. And I guess some of you might know that case. And let's assume that the product owner or product manager comes by to our desk and says, hey, we need another property return for the list page because our users need to see that. And you can already imagine it's cumbersome to add that feature here. Why? Because we would either have to do it in our author repository, we would either select it afterwards, or we create another method in the repository itself to do it just for that use case. There are different possibilities to solve that feature request from the product manager. He don't really cares how you do it. It must work at the end. But yeah, I think you all know that setup. And yes, that's it for the showcase. Let me just switch back to my PowerPoint. And here I created the structure again. It's clean architecture, but if you visualize it this way, it's the same. You have an API layer calling the business layer and the business layer calling the persistence layer. And as I already mentioned, I was in projects where we have a few thousand lines of controller, service, and repository, and maybe you call another repository from the device service because you need to combine data and build the business case there. I see people, how to say it, people nodding, thanks. And yeah. And so on. Let's assume you built that software about 2 or 3 years, and it might get very cumbersome to add features there. And just one short quote: if you have the feeling that something will break at one end if you change something elsewhere, then maybe it's time to think about refactoring your architecture. Who am I? I'm Alexander Pabinger. Here's the QR code for my LinkedIn. Would love to connect with you. I'm a freelance software developer. That's the reason why I'm standing here. Otherwise, I would sit in your seat and grab a beer, drink a beer. I studied business informatics at JKU, and I mostly worked in my professional experience in product-led software companies. So I built software as a service product all the time. I tell this story because I always touched my code twice or more often, and you know that meme. And I'm married. Just a few information about me. I have a son with 2 years. You may also know what that means with 2 years. And I play trombone and baritone at the local music society, and this weekend will be really hard because we go Maiblasen. I don't know if anybody of you knows that term, but we get 1 or 2 drinks at every house where we play something. Yes, and for anybody of you who does not know how a trombone or baritone looks like, here I put pictures of them. That's all from me. First of all, I would like to start with a short theory unit before we get to the actual code. What is software architecture? And I guess if you ask most of the people here what software architecture really is, they say this is the structure of the system. What software architecture do you use? They will answer with, we use clean architecture. We use microservices. And this is the main answer you get, but in reality, software architecture is out of 4 pillars. This is from Fundamentals of Software Architecture. I can really recommend this book. It's worth reading it. I got it from a former colleague who is a living library. Some of you may know him. And the 4 pillars are the structure of the system, the architecture characteristics, the decisions, and the design principles. I won't dig too deep into that topic, but I think it's worth mentioning it. And the structure of the system is, as you all know, like microservices or layered architecture. You see it at the top left. Here we have a layered architecture. We have a microservice backend, but the monolithic user interface, no micro frontends. We have a plugin architecture. This is what is called the structure of the system, not the software architecture. What are architecture characteristics? You can see them as success criteria of a system. If you design a new system, usually what you will do is you pick out 3 or 4 of the most important ones for your software, and you will keep an eye on that and build your software upon these decisions. And it highly depends on the domain, because not every software has to be available 24 hours, 7 days a week. Or not every software has to run with the same load for 24 hours. Just say we have a peak at lunchtime or anything like that. So these are some architecture characteristics. They are required for the system to function properly. Sorry, I have to get one sip. I was ill this week, sorry for my voice. I ate ibuprofen like bonbons, but it doesn't help. Then the next thing are architecture decisions. They are strict rules which should be applied to your system. So in this example, only the business and service layer can access the persistence layer, not the presentation layer. All software architecture structures, aim for the same principles, so that you have a low coupling, that you can have a good testability, that you may exchange your data access, so you want to create an abstraction for that. All software architecture structures, aim for the same goals, let's say. And the last one are design principles. These are rather guidelines than rules. In this example, one can say use async if possible. I think it's hard to enforce that with tests. The architecture decisions. There are architecture unit test frameworks where you can enforce that, where you can say, okay, no code from my project is calling a class from another project, but these are rather guidelines and are enforced with pull requests. You can write that down in a wiki, but nobody will read them a few weeks after that. So I assume you will do that in a pull request, but you all know that kind of stuff. Then what are the expectations of a software architect? Lead developer, expert programmer? No? No expectations? Any of you, any expectations to a software architect? Any ideas?
Stick to the architecture.
Stick to the architecture? He enforces that we stick to the architecture? Yes? What else? Any other idea?
He actually develops the idea of the architecture.
Yes. But he...
What he has in mind, and he can tell his colleagues where to go.
Yeah. Thanks.
Predict the unpredictable.
He's a magician. Maybe, because of his experience. The core expectations are, we already heard that he should make architecture decisions for sure. He should continually analyze the architecture because the software evolves over time. We got new requirements, a new user base, and he should continually evaluate the architecture. He should keep current with the latest trends. I guess all of you is doing that because you're sitting here. Maybe just because of the food and the beer, but you also want to hear something new. He should have a business domain knowledge. In my opinion, this is one of the most important expectations to an architect because he can only make good decisions based on domain knowledge because that's the most important thing here. He wants to solve a business problem. There's a business case behind the software you're building. You're not building software, or hopefully you're not building software just for fun. Maybe at home, but not in your professional context. You should possess interpersonal skills because the software architect is not the only team member. He also has developers in his team, and he has to communicate with them. He should be a guide to them. He should not decide that we go in this direction without talking about with the developers about where we go. And he should understand and navigate politics. Why is that important? Because the software architect itself is some kind of man in the middle between the manager and the developer. He also has to talk to the management that if at some point in the future we have to do a bigger architecture refactoring, he must talk with the management about that and explain to them why this is important, because they just want features, they want new customers, they don't understand that software is a complex thing. There are also some laws of software architecture. The first one, I really love it, is from Philip Pendelin, who is from the Softwares. Is anybody here from the software people? No? I really like the German word, the German quote. Irgendein Tod stirbt man immer. You always die some kind of death. And I really like to keep that in mind because that's so true. Another law, which is, in my opinion, the same, everything in software architecture is a trade-off. And another law I really like is, if an architect thinks they have discovered something that isn't a trade-off, more likely they just haven't identified the trade-off yet. And the why is more important than the how. And I know you all had a busy work day today. You're chilling here, and I hope you don't get too tired. But let me just show you a few slides before we jump into the Rider project. Cohesion. Hopefully everybody of you knows what cohesion is about. Cohesion is the degree to which the elements inside a module belong together. I like to say code that belongs together stays together. And who knows what the big brother or sister of cohesion is? Coupling. I already talked about that. And coupling is the degree of interdependence between software modules. And I already mentioned that software architectures aim for low coupling, and therefore they provide structures like the clean architecture or onion architecture and so on. With coupling, the thing is the higher dependency means more likely destabilizing effects. Because if you have coupling between modules and you change one thing at one end, it may also impact the other one. Then let me just jump to CQS and CQRS, and you will see afterwards why I'm telling you all these things. Who knows the difference between CQS and CQRS? It's not that hard, I think. In CQS, it's meant command query separation. You split your methods into commands which mutate the state, and queries just read it. They use the same underlying data store, but that's it. You just split the methods, nothing more. In theory, commands do not return data, but I don't really like that, and as software architect, you also have to be a little bit pragmatic, in my opinion. And in CQRS, you split the whole system in a command and query side. So you may also use different data stores or read models. Let's assume you use a relational database like Postgres for your commands. You use Entity Framework for that, and because the change tracker is really nice and the OR mapper does a good job. But for the read models, it's not that fast or not fast enough for your domain. And so you use Dapper there, or you just use a Mongo, a NoSQL database, where you have some kind of projection from the relational database to the NoSQL database. So you split the entire system in two different parts. And the last thing before I jump into vertical slices is the 5C design. This is not so well known, I guess. This is from Herbert Duvalil. Duvalil is an Austrian author and software architect. I took this from his book Modulare Softwarearchitektur, and he created a, let's say, pattern or design system which is not for compilers or interpreters. They don't care. It's completely unimportant for them how you structure your project. It's for you to keep it maintainable, to be fast for new features, and this is exactly what the 5C design stands for. And the 5 steps involved in that are cut, conceal. I don't have to tell you this because you're all .NET C# developers. You write interfaces for everything. Contract, connect, plan dependencies, and you should plan them explicitly. You should know, I think I saw so many projects where the dependencies are not used explicitly or planned explicitly because they were not really enforced by using like projects in a .NET project or repository where you can say, I don't reference this project. And you would see that in the CS project file, in the pull request that the new junior developer added this reference to this assembly. But there are also projects where you only have the folders and you just import it, and it's, it can be that you have dependencies which you never wanted. And the last one is construct. Software engineering is an engineering discipline. Construct higher components or smaller components into higher ones. And in his cut, I only will talk about the cut. You can cut it horizontally or vertically. In the horizontal cut, you see it like in the project I already showed you. You cut by UI, by service, by database, by technical concerns. Or you could also cut vertically using features. So what is a vertical cut? It's a vertical slice, a use case. And in this use case, you want to build a business capability. You group classes, methods, and files per feature, and they all contain the necessary code to fulfill a feature. That's not always possible, but most of the time. One misconception about vertical slices is that they do not share code, but that's not true and not possible. You may share code, you may share business logic, pull it out into a service class, you may share the same underlying domain layer, you may share some DTOs, but you should keep it really small. And not to confuse with clean or onion architecture. Everybody of you reminds of my survey question where I asked you which architecture do you use? But if you use clean architecture, this does not exclude to use vertical slice architecture because they go hand in hand, in my opinion. The architecture structures aim for a low coupling, as I already said, and the vertical slice architecture aims for a high cohesion. And this should be the goal of our system: low coupling, high cohesion. What are the pros and cons? You see, I'm absolutely not opinionated on that topic. Maybe we can talk about a few cons afterwards. But the pros are improved cohesion for sure. It's easy to extend or update features. I will show that to you in a minute. It's less likely that features impact other features because you don't have that underlying service or repository layer where you access the code from there. And you use the same programming model as always. That's why I really, really like it. You don't need an event-driven architecture. You don't need pub/sub. You don't need messaging. It's just you build your REST APIs, and I will show you how to do that. And you call your handlers there with CQS, and that's fine. You have infrequent merge conflicts because you did a vertical slice. You don't have that big service classes, and the dev experience is really nice. That's not all only related to vertical slice architecture. It's also related to CQS, which we will use in a minute. The cons are you don't get rid of coupling because you may share or you may have business logic which you want to extract into a service class or some other project which you will depend on. So you don't get completely rid of coupling. And another thing is code duplication. Why? Because you may have a team of 5 or 10 developers and each of them builds his own features. And a new developer, if he creates a new feature, he may not know that this feature or this code already exists and writes it on his own. So there may be some code duplication where you also have to be aware of. Now, let me jump to the sample. I will just check the clock. Perfect. So writer is here. Let me switch branch. I created the main one. Check out.
We don't see it.
Ah, you don't see it? That's bad. Thank you very much. Here we have it. So let me just check my handout so that I don't forget anything. Here you can see we have the same structure. We use clean architecture. We have our project, our application project, our domain, our host, our infrastructure project, where we have our DB context in it. And here are the 2 lines, which could actually be 1 line, where we register our CQS services. You could also do that with Mediator, but you know Mediator goes commercial, and I don't think you need the overhead of Mediator or the complexity of Mediator. You can just use this package. This is from the software people. We used it in our previous company. It works fine. It is open source. It is really small. They use it. We used it. I use it in new projects. You can decide it yourself if you want to use it. It's really, really simple. But here we register the software CQS in our service collection, and we include the types from API path, which is our assembly of the application. Yes, and now the product manager wants to extend a feature. Let's jump into the features folder where we have a pizza receipt, and we go to the feature where we have get all pizza receipts for list page. Everybody of you knows what this code should do. I decided to create a static class for grouping the code. You could also use separate classes. You could also put them in its own files. I don't really care. In this case, it was really easy to do that. It's just a small showcase. You can do it how you prefer it. And here we have the same. We have the map endpoint, the minimal API, which we register for the list page. I also like to call it like them. And we inject our request processor. We get it from the software package where we register the request processor as transient service using the dynamic request processor from Microsoft. And here, the only coupling you have between your API and your business logic, your service which returns the data, is the command or query. Here I've created the query class, which implements the iQuery interface and returns an INumerable of pizza receipt details. An iQuery implements the interface iRequest. This is the base interface for all types for iQueries and iCommands using the generic type tResult. And we say we have a query with an empty body, an empty class, which implements the iQuery interface. And then we create our corresponding handler. The handler also is of type tRequest and tResult. And therefore, in the dependency injection, we know how they belong together. So if we call it here the processor handler async, we know the query belongs to that handler because of that here. And here we say it implements an iRequest handler of type query, which is the tRequest, and returns the list result. And what we get from that interface sorry, is the handle async method. And what we do here is just calling our DB context and getting data. And now let's assume the product manager comes by and wants to extend that feature. Let's say he also wants to return some authored data. If we would use a repository, it may be kind of hard, because if we just use the same method in the repository to get the pizza receipts as everywhere else, we cannot just simply add and include. Then we would impact all other features. You know what I mean? Or you would create another method in the repository. What you can do here is simply .NET stuff, you know that. I just want to show it to you. Include the author, and we include it here, p author. Let's just say first name and last name. And because we have the response also here in this file, we just have to say string first name, last name. This is not true. And we just extended our feature for our product manager. This is really, really nice in my opinion, and it's so fast. And trust me, we built the whole software in my previous company using CQS and these methods. I will tell you a few things we did in our project, but yeah, let's keep it like that. What is also really nice with that is that we can build cross-cutting concerns. So let's say we have a cross-cutting concerns like transaction, logging, authorization. How we can do that? We have a base interface, an iRequest, where we get each handler. So let us just build a directory with a decorator, and let's say we want to track the command time spent. We want to track the time spent for a command, right? And how we can do that? Let's say we have a command time spent decorator hardware of type tRequest, tResult, implementing iRequest handler of type tRequest, tResult. That's true. Import missing references. Then we get the implement missing members, and we get the handle async method. And now what we also want to do, we want to inject the current handler in our constructor. I will use the primary constructor here and say I inject the request handler of tRequest, tResult, handler. Let's just use the primary constructor here. And here we say, result is awaiting the handler async and returning that result. This would do nothing now, just calling the handler which it originally should call and returning the result. What we now want to do is we want to track the time spent, so we create a stopwatch where we say new stopwatch start. We'll wrap that stopwatch stop, and we do a simple console write line. Yes, software elapsed milliseconds. Here we have it. Now we also have to register that decorator, because how would our software know that it should call it? We have it here at decorators, where we get the builder's callback and say builder at request handler decorator, which needs a type. Here we can use type of time spent, how did I call it? Command time spent with a placeholder. And here we registered our decorator. Let's start the application and let's check if that works. Yes, here we have our Swagger documentation built with Scala. Let me just call here the get author by name request, where we say A and we get the data here. You all know that. And we have 54 milliseconds, which took our API. And I only wanted to track commands. I don't want to track requests. And I can do that by just saying that where tRequest is of type I command. So let me restart. Let's check if it's also working. Here we have the same result. We have no console write line, and now we will create a new author. Let's say ISDF, send it, return the ID of the newly created data, saved 1 entities in memory, and 27 milliseconds. That works like a charm. And you can imagine we built our whole system with that structure using CQS. We had a really complex authorization setup. We created a special authorization decorator. We used an attribute in the command, which we put on a command property. And then we could say, if that decorator existed, does the current user has access in a complex setup to access this entity? Does he has the permission to access this entity? And this really works nice. And if you start with a new project, maybe you don't know where the project will go in the future, or maybe I guess it's the case. With that kind of architecture, you can do that in a few months without touching each layer twice. So that's it. We used CQS and vertical slice architecture. And what are now the technical aspects of vertical slice? Vertical slices are, as I already mentioned, about business capabilities. It's not about architecture structure like microservices or clean architecture. Business capabilities are about the what in a system, and they can be used everywhere with every architecture. And what I think is really nice, and I think you will admit to that, if you are a small project team, you won't start with a microservice or a monolith. You will start with a small monolith building features for your business. If you use vertical slice architecture in CQS, and in a few months you want to pull out code from there to create a monolith or a microservice, you can do that easily. You just have to pull out the features. You have to pay attention, I have to admit, to if you have underlying shared services. That's true, but you will recognize them. But it's really easy to pull the code out in the future. Now, should you use a repository? It depends. I don't really like repositories. I have a hate relationship with that because I've seen repositories with 5,000 lines of code, and we always talk about the single responsibility principle, and then we have a repository with 5,000 lines. Yeah, the single responsibility might be that it gets data, but for 17 different use cases. It depends, because you should decide if you need an abstraction for DB context. I also saw projects where you have an interface called IDB context, where you have properties where you use the DB set in there. Then the abstraction does not really make sense, in my opinion. Yeah. And you could just simply use the DB context itself. How we did it? We used the DB context in all our queries. We said this is an architecture decision where we had the rule that we use the DB context in our query handlers. It was really, really fast to build the features. What about command handlers? Maybe you want to unit test them. We decided to create a data access service per command handler. We discussed if we should use a repository and maybe share the repository again, but yeah, I already said what I think about that. And we created a data access service per command handler. This might sound cumbersome, but we had a small command line tool which scaffolded our classes and folders, and it was really fast to build new features. And we could just simply unit test our command handlers, because at the end, it's just a simple class doing stuff, and that's it. At the end, it's all about ETC. And no, that's not an alien. It's about easy to change of the system. This is from the Pragmatic Programmer. I can also recommend you this book. Every principle, every software architecture structure, most design patterns aim for easy to change. If you build software and you have 4 or 5 different paths to build it, choose the way where it is easy to change in the future. That's it from my side. I'm thirsty. I think you hear it. You're also thirsty. So thank you very much. If you have any questions, please ask. Here's the QR code for LinkedIn and the link to the GitHub repository. Thank you very much.